So welcome, good morning everyone. This is Johannes. I'm Voy. If you have any questions, just raise your hands or shout out. We're here for the DX11 beginner workshops, and for anyone who hasn't got it, the data is on the data server. Get it? And who of you has been patching already? Even before Node? And who has been doing DX11? Who knows programming? Like coding? Okay. Who knows the X9? X9? The thing, the old thing? Okay.
So you've written shader in DX9 as well? Or okay, so like total shader beginners then. So okay.
Okay, maybe as an explanation why we have this DX9, DX11 thing. DX9 was there from the beginning on in VVV, and then Vux came up with the great idea to implement DX11 for VVV. It's kind of the same, but it's kind of better. But in order to be able to get more out of VVV, actually you have to at some point write shaders to get the full power of DX11. So we're gonna start with like patching in DX11 and what are the differences to DX9, and then we will immediately go into pixel shader writing and vertex shader, geometry shader, this kind of things. But don't be afraid, everything is easy, and yeah. For any questions, just shout out, okay? Everybody has this thing running? Some of the workshop files are like rather old, like from the beginning where it was implemented, and at that point some laptops and desktops, graphics cards wouldn't like support DX11, but right now I think it shouldn't be a problem anymore. So in case you don't see something, it might be that your card doesn't fully like support it, but that should only happen if your laptop is like older than 6 or 7 years, so probably not a thing anymore. Any questions so far? The beginning will be a little bit more theoretical, let's say, so in case you're still tired, you don't have to click along, you can just listen and watch. Who knows 3D, like modeling or gaming stuff? Okay. So you all know when you want to draw something in VV, you need a renderer, and for DX11 it's called DX11, renderer DX11. And there are some settings which are off or different by default, which you might want to change if you're doing like 3D. So it's listed here. Depth buffer by default, like the depth buffer mode here is on none, but as soon as you're like working with spheres, cubes, and are doing something in set, you might want to turn it on. And standard for the most of the time is good enough. There is VSync, which you might need when you're going full screen and want to like be in sync with your graphics, with your monitor, and see some weird stripes going through the through the picture. So here's the toggle. You can show the cursor, which is nice for debugging things, and if you want to, like in the workshop, show things to other people, because by default it's disabled, so you don't see it when you hover your mouse over the window. Anti-alias, you know the term probably. So the corners of the geometry looks nicer. It's default to 1. You can set it up to 8 or whatever, or 16, whatever your graphics card supports, but it also costs some performance, so it's always the balance between it looks nice but it takes too much time to compute. Yeah, the rest is back buffer is also interesting. It gives you the actual size of your render window, like this. If I open it up and hover over the pin, I see, okay, now my render window is like 740 pixels by 540 something. Of course, you get the texture out of the render window again, so you can pipe it somewhere else. So whatever you do in your render window, whatever you see there, you can reuse it somewhere else in the patch. And you get the present time, which is nice for debugging. It's like how long does the this renderer need to compute and to draw this picture. So this is kind of, if you're like running slow, if everything is shaky, you can check this one and you see, okay, maybe everything above this renderer is like taking too much performance to compute. And the query is also some debugging info, which we're gonna go into later. So this was the renderer.
May I ask you something?
Yeah, sure.
There's no difference, like validators 9 between the Windows buffer and the full screen buffer, right?
No, this is just one setting here.
Yeah. And so far there's still no actual full screen mode for DX11, so whenever you enable the full screen, it's basically fake full screen. It's windowed rendering, but yeah.
Could you comment a little bit on what the depth buffer count is for? Or buffer count for them?
The buffer count?
It's, yeah, buffer count.
The second one.
Yep.
I actually haven't ever used it, so far it wasn't of concern for me. Do you know?
It should actually be it's not the depth buffer, it should be the back buffer, which is like the buffer the graphics card renders the picture into before it swaps it onto the screen. So you have like, you can render like more pictures and then at some point exchange it with the one you see. I think it's needed if you're like computing faster, like for stereoscopic things, if you're doing things on like on 120 Hz or something like that. But it's mostly like very specialized applications. And I'm not even sure you can make use of it on like gaming graphics cards. It's more for like these Quadro and this kind of stuff. So let's see something.
Kannst du mir das gerade transparent machen, das damit erklären wahrscheinlich?
Ja. Okay, one big difference between the standard, how the rendering looks like in DX9 and DX11 is that in DX9, if you would change this alpha pin on the quad, this alpha, you would actually by default see a difference. But as you see, nothing is happening, and this is because by default in DX11 the blending mode, like blend mode add or blend multiply, whatever, is just disabled, so there's no blending. It's just drawing one thing after each other, And this is also a performance reason, because in 3D you cannot properly deal with alpha anyways, so Wux disabled that one. So if you need alpha, you have to use the blend node, which is called the same as in DX9. And you see here it's disabled, and if you set it to blend, it's just like you've been used to in DX9, that you can actually change the alpha value. The rest should be about the same. You can have it on add mode, multiply, alpha add, and the text default, I'm not really sure. I think it should be like source blend 1, destination blend 1. The important thing is that if you want to use like blend modes, you have to enable them. In case you did DX9 patching before, there was this rasterizer, there was cull and fill, which is now called the rasterizer, because the correct term for all these things are rasterizer. It's the rasterizer stage, in case you want to look it up. This one is more interesting on the sphere actually. The default here is back cull, simple. It becomes clear what it is. You can set it to wireframe, so you see the sphere as a wireframe only. You can also set it to front culling, which means, okay, show me just the other sides of the triangle. So
disable the quad for that maybe.
Like this you wouldn't see a difference, but you're looking through the sphere now, because the triangles in front are now like invisible. You just see the ones in the back which are facing towards you. That's why we have the quad here, so you see, okay, it's only drawing the back side, the inner side of the sphere. And sometimes the models, the 3D models you might be using imported from somewhere else, might have that flipped, so you need that setting to be able to show the outer side actually. But the standard is back cull simple. And you can also set it to no cull, which means draw both sides, but that also needs a little bit more performance. Depth stencil, like depth is a huge thing if you're working in 3D. If you have the depth buffer turned on, the graphics card will sort the objects for you, so it will know, okay, this plane is actually like in between the sphere, so draw half of the sphere and then draw the quad and then draw the other half of the sphere, and or don't even. But sometimes you wanna just ignore this position, in case you wanna, for example, draw this white quad in front of the sphere. You have to use the depth stencil and just set it on no depth. And when you do that, it will change a flag, and the drawing will be like the order where you connect it, where you connect the shaders or the whatever layer to the group. So first it will draw the sphere, and then it will just draw the quad, and completely ignoring where in space it actually is. It will just draw over the rest of the scene. And the convenient thing about DX11 now is that the group node is actually much more powerful. It's not just for like getting more layers or shaders into the renderer. You can actually plug those render states, for example, directly onto the group, so you don't have to like cable it to each object you're drawing. You can use the rasterizer here and set it on wireframe for everything that is connected to the group. Any questions?
If I rotate the camera around the thing, what is not drawn on the other
Yeah, it's because of the culling. So the normal looks towards the camera, and if you go around, then by default in DX11 you won't see the other side. So that's, for example, which you will also notice when you download some 3D model and it's got flipped normals, you basically see through the surface. So that's what's happening there as well.
That was the thing with the front side and back, front and back. And if you set it, for example, here on no cull, then you will see it again. Like then the graphics card will draw both sides of the quad. But the standard is back because for like closed 3D objects you just see one side and it's just the outer side, so it's needless to draw the inner side. Like a lot of settings in DX11 are really set to like have the maximum performance in 3D, while in DX9 it was still like, okay, it should be like convenient for both 2D and 3D.
Yeah, so now you deliberately have to set a setting in order for it to like do its work. So it's like not as beginner friendly anymore. So for example, the question about why alpha doesn't work when drawing stuff in DX11, that's like a question that's been asked in the forum every 2 months at least. So you have to get what's actually going on now.
Or maybe it's because Vux doesn't like 2D drawing so much. Might also be. Is it actually too small? Do I need the magnifying or is it okay? What? I cannot a little bit, that's a problem. I can only have like 100 and 200, so it's like this. Okay, validators, that's something we didn't have in DX9 at all. Just to say, it's more for debugging purpose because it's not really performant, but it's really handy at some point. And as I said before, the group is like greatly promoted in DX11. For example, for the validators, there's a hidden pin. If you open up the inspector on a normal group, you will see that this is like it will look like this because it's hidden. So just click on the group, enable validators, and you get that extra pin. And what you can do with these things is work on the layer output actually. In DX9 you couldn't do anything anymore as soon as something was a layer, but right now you could have a get slice, for example. So get slice, even if the layer sends more objects, you can just choose here which one it should take. But it actually does this for every layer which is coming into the group. That's why on index 0 you will see the quad and the first box, and if you push the number up you will only see the boxes, because it's trying to take the third quad, but there is no third quad, so there is no quad anymore. But there is a third box, so it will be drawing the, oh, it's a fourth actually, the fourth box. Get slice is a little bit confusing here because it's not actually spreadable. You can only get one. If you want to get multiple, if you want to choose like multiples to draw, you have to get the get multi slice. So you can choose, okay, I have 81, but I just want to draw 0, 5, index 0, 5 and 20. Yeah, and you have remove slice to remove like one object. You have get spread to get a sequence of objects. You can select like with the select node. You have frustum test. Who knows what a frustum is? Oh, that's not so much. The frustum is actually okay. Where do we start? There in the bottom you have the camera, and this is actually really how the drawing works. You have like the word where you put in all your stuff, then you define the view or the camera position, like how do you look into the world, and then you have the projection, which means okay, in like what kind of angle or what kind of properties does my camera or the view have that look onto the world. And for a perspective camera, it's always this kind of cone which looks into the world, which is like a cone, and everything that is within the cone is like within the frustum. It's called the frustum because it's not just a cone which goes like endlessly. It has like a near plane in the front where it cuts off and a far plane in the back. So there's like a box, a tilted box, which like in which things are drawn.
Imagine the near plane to be your computer screen, and from your computer screen it extends as a cone into your virtual world. And if it was just like straightforward, that's like orthogonal projection, which means that everything, even back there in the distance, sneakers would be drawn as life size onto my screen. But when you got like a perspective projection and the far plane then is way much bigger than your near plane, then you can imagine like everything that's in the very distance would be scaled down to fit on your screen in front, and that's why objects in the back would then appear smaller than the ones closer to the camera.
Like with the zoom lens or a wide angle lens. So if you have a zoom lens, the sizes don't change so much in the distance, and with the wide angle lens it scales down immediately. Okay, and the frustum test means, okay, please discard everything that is really out of these bounds, which are outside of the renderer. So if you connect this one, you will see, okay, 730 triangles have passed the test and are actually within this view. And as soon as I like zoom into, you will see, okay, they're starting to fail. So it's really starting to discard some of the cubes which are now outside of the bounds of the view. Yeah.
It affects the performance? Or
Yeah, of course. It's always better if you draw less, because the graphics card doesn't have to do so much.
so if you don't put this node first from tests, the graphic card will calculate everything.
Yeah. But it comes with some limitation, which we will go to later.
It's always better to just draw what's really on screen.
So it's even better if you, in the beginning, already know you don't want to draw it, so you disable it even before. So the nearer you go to the graphics card, the more performance it needs anyway. So if you already know this won't be drawn, just disable it yourself.
Gehen wir weiter, oder?
Yep. For everyone who wants to like combine like 3D scenes and maybe some 2D objects in the front, like for example for UIs or whatever, to show some text, or in DX9 you had these how were they called actually?
The same. Was
Yeah,
this
about the same.
transform, yeah.
these within something nodes. In DX9 they were like transform nodes. You had to connect them to the transform in, although they weren't really transforms. And now in DX11 you have them as like in between the layer. So if I want to have this round rect drawn like not in 3D but always in 2D, I would use this one. And so even if I rotate my camera, which like, okay, let's do it like this. I rotate my camera and I connect it again, and it will always like face to the camera. And so there's within view and within projection, so it will always stay more or less in the same place. And within view means it will always stay like orthogonal to my camera, but it will still move in the depth. And within projection you have these nice little things that you can preserve the aspect, which won't make a difference here, but it will at some point. Yeah, this is nice if you want to draw like, yeah, score winning, or if you want to draw a button where you can actually click on. So semantics. This is something maybe completely new as nodes. You had that in DX9 when you were writing shaders, but you didn't have that. You didn't have it anywhere else. We're covering it here because it's kind of still patching and it's on the group node. Again, this is a hidden pin. Normally you have custom semantics and custom semantics and resource semantics as hidden pins on the group, which you can use. And what is that? If you open up a shader, this
by right clicking on it, by the way.
So everything that is after a colon and always written like in all caps is called a semantics. So this is a variable, this is the type of the variable, and this is a semantic. It's like decorating the variable with some special name. For example,
yeah, these ones you see there, like position and normal and world, that's all what DX11 basically already gives you. So it already has a meaning.
So this is why this pin is called custom semantics, because you can give like your own names if you want to access them somehow specially. But just to give you an example, this for example, TW, this is a transform and it's called world. And because it's called world, VVV and DX11 know that it's actually this transform in pin on the shader. So this is why you need these semantics, because it could be anything, it could be any transform, but by writing world, okay, the system knows, okay, this must be this main transform input pin.
Is there any documentation about the standards for V for the?
Yeah, you can find it on the Microsoft website. It's just DX11.
It's not even like VVV standard, it's really like DirectX standard. So this is even the same, mostly the same between DX9 and DX11. There are sets which are like predefined, which you can use.
Yeah, Google for the term DirectX semantics, then you'll find all these. But we'll cover them later anyway.
Yeah, and the funny thing about that is now, like, if you have a shader which defines a custom semantic, like we did here, there is the custom world. So the custom world is not this transform in pin anymore. Whoops. Does it work? Yeah. So we're not here. So this one does not have any effect anymore because we called it custom world. But now we can input the transform via the group. And the convenient thing about it is that you can actually have multiple shaders with the same semantics. So you can have the transform, for example, on all of the objects instead of like cabling it to each one. Everything that is connected to that group will receive this transform.
Yeah,
and you can do that with colors, and you can do that with vectors, or you can basically do that with anything.
Yeah.
So you mean the input bit of the node render semantic will adapt its...
No, it won't add to it. You have to reference in the shader, then you can just use the value there. So for example, if you had more geometries shaded with another form shader over there, and you set it to different colors, but you want your scene to have like the same light source at the same point, you'd have to set it separately at every shader input. So you had like a 3D vector for your light position and connect it to like 10 shaders. But instead you can just discard of the light position input in the shader and just replace it by something with a custom semantic, and then you just add that vector once with a custom semantic and reference it there. So it will then maintain the same light position in all the shaders. So that's something that's, I guess, a good use case.
Does it answer your question?
Okay. I just felt like there was 16 renders each for one type of data types.
Sorry?
A render semantic, there's different data types.
Yeah, you have the cons, so you can get them all together. But this is needed so in VV you can actually connect them, because you didn't have this possibility to connect like transform and color and value, but you can have them in the shader. So there's like one type for each.
Okay.
Yo. You see, we're like rushing through these slides because it's gonna be more interesting later when you can get your hands on it, and then probably the questions will come. So, of course, you again have textures in DX11, Wonder. That's pretty much the same as in DX9, just that there's now a difference between 1D, 2D and 3D textures. Like, it's not the same anymore, so if you wanna load an image, you have to choose file texture 2D, because it will most of the time be a 2D image. And if you're loading something volumetric, you have to use the 3D texture. And in DX9 it was one file texture for all of those cases. And also the dynamic texture, where you can set like the pixels yourself. There's also the differentiation between 1D, 2D and 3D. Yeah, and it works like, let's see, which is this one? Green. So if I connect the green dynamic texture to the object, everything will be green. Pretty simple. You know, file stream, you had that in DX9 as well, so you can, it directly has the texture output, so you can play the videos. You have the info node, so you get the info out of the texture, so how big is it, what kind of format does it have, what resolution. You have the standard video in to get your webcam. Hi. One convenient feature of DX11 is that you not only get the texture from, like, this is the renderer, so this one is this one, and this is the preview, which is here. So we're getting like the picture of the renderer. We're drawing what we like. This is the picture what you can see here, because we're getting it here. And in DX11 you have the additional pin of the depth buffer, so you actually get the depth scene of the which the renderer has, like for free. You can look it up here. Oh, it looks pretty boring. You see it like on my screen. Oh man, wie geht denn das? Mit Mausladung.
I set it to a different camera type that he's not used to. So yeah, if you get closer to it, then you can see that the pixels closer to your camera will get darkened. And yeah, there's this linear depth in between, as the depth buffer is logarithmic. So data or like yeah, depth values that are closer to your camera are in a higher resolution, and in the distance when you get closer to the far plane, it won't be as accurate anymore. So in order to have like a human comprehensible image, like here, you need to somehow get rid of the logarithmic range and just put it back to a linear, and then you'll actually see that everything is yeah, in a actual relation to each other that you can understand.
So you need the depth buffer for like post effects, like for what do we call that, lens blur or
Depth of field.
Depth of field. You need the actual information. Okay, this is the plain picture in 2D, but where in space is that actually? So you know how to like blend stuff into each other, or which part of the picture to blur and which one not. And that's the depth buffer, which is just linear information of, okay, this pixel is in front or this pixel is in the back. Questions? Yeah? Yeah.
What's the difference between the different file texture nodes, for example, 2D pools and 2D?
2D pooled is like is made for like fast texture stack loading. So if you just want to load one picture, it doesn't really matter. 2D pooled creates a texture pool, so it doesn't have to like create new textures for each image which is loaded, so it can load like faster without blocking. So with the normal thing, just loads one image, so it reads it from disk and then puts it onto the graphics card. And if you do that with a lot, it will take a while, and the pool will like try to reuse, for example, old, because it's supposed to work like, okay, you have like thousands and you just load 100, but you do that sequentially, so the node knows, okay, I will like reserve space like RAM on the graphics card for like 100, and like try to, if I'm requested to have a new one, I will try to reuse an old one and won't discard that. It's kind of a performance and memory optimization, but it's not so much in use because they're like specialized image stack players anyways.
It's that's the same pooling technique is, for example, used in video games, not only for like textures. For example, if you got like a small spaceship and you fire bullets somewhere, or like laser beams, then maybe you have a set already, like a pool of about 20 beams in place that are just not being drawn. And then if they hit a target, they just hide, and instead of being discarded, so the garbage collection has to get rid of all the old objects and then spawn new ones and create new objects. It will just put them at like the center again and then reuse them. So it will always be the same amount of objects in memory then. It's also like performance issue.
So the primitives in DX11, they're mostly the same, like you won't miss a lot. There's the quad, there's grid, segment, round rect. You can try all of these. There's the polygon, which is kind of new. There's also Bezier patch, which didn't exist in DX9 at all. What is missing is the teapot actually. But Vuk said now we have the isocahedron, but I think it doesn't look that great compared to a teapot. It's meh. You can cons geometries together, so you can do it like this. I want to draw a grid and the icosahedron. So this Phong is now drawing both of them. This wasn't possible in DX9 as well. For the standard geometries, you even have this bounding box object node. You can just connect one primitive and you will see where the minimum is, where the maximum is, if this thing is, if the bounding box is valid. So connecting the icosahedron, I will know, okay, the minimum is 1, 1, maximum is 1. You can load meshes via the scene file. So this one should it be loaded already? Yeah, mesh.
No, it's set to an old path.
Okay.
You have to reference the file again since yeah, that workshop was last held with an old version. Wahrscheinlich brauchst du noch die World Transform, also Ascent Node.
Well, it should work. Too lazy now. Achso, ein Geometry File wäre schneller. Well, fuck it. I'm completely lost here. Well, you have to believe me that it's possible to load geometry files. It's really hard to navigate this thing with the... Any questions about this? I think this is pretty self-explanatory.
What kind of files will you use for geometry files?
Actually, it's the asymp library which is being used. So you have to look it up on asymp actually. Yeah. But it's for sure like X files, Collada files, FBX.
FBX in some cases, but just not all the features supported. OBJ works as well. Yeah.
Like I'm sure all the open source ones and some like half proprietary at least.
Yeah. But it doesn't make use of all the FBX features, for example. That's why MicroD just did that other importer.
So, but you cannot only like have load primitive geometry or load your 3D file, you can also create it yourself, of course. Here's an example. Here, this is actually like 2 examples how you would do it. Like the simple way would be to use the mesh node and give it some points in space and some texture coordinates, and then you're done. You can connect it to the constant. So what I need to draw quad is actually just 4 points in space, which I can define. And the more elaborate one is the indexed geometry buffer. where you have to specify a lot more what you're actually giving to the graphics card. For now, most of the time the mesh node will be good enough. The index will get later to that one. And for like simple plane shapes like a quad or a polygon, there's actually the polygon node. So only if the thing gets a little bit more complex or has more depth and more vertices which are not like connected in a row, then you will need this mesh or indexed geometry buffer nodes. If not, you can just use the polygon. It will just lay out the points one after another and connect them all.
Yeah.
Question. DX11 and 9 was possible to split like a mesh.
Yeah.
You load in a mesh and you got all the values and play around with the values. I don't know.
Yeah.
And join it again and then have a like morph the mesh or something.
Some of the asymp nodes, like the mesh, there's a mesh split for just the asymp importer, which failed on me in some cases. And now the general approach, you can find, for example, in the instance noodles pack, there's get vertex data, and what it does is basically in a compute shader just runs through all the geometry and pulls out the data and gives it to you as a buffer.
Okay.
So there's no actual node for this. Yeah.
So either you have it as a 3D file, then it's a little bit easier, and if not, you have to use the other way, which is not really like performant, I would say. So it's just not the same pipeline as in DX9 anymore, so you cannot do it that easily.
If I use the index geometry buffer, how would I specify the normals?
You'd have to add another input element, and then at the leftmost pin where you have the zip with the bin size of 3 and 2, then you'll probably he shows you.
The thing is, if you want to give geometry to the graphics card, it doesn't actually have an idea because what type of data it has to expect, because I mean it's not just the position in space which it should connect. You can input a lot more data. That's why there is this index geometry buffer with a lot of options now, because actually you might want to make use of that. For example, here we just have like position, which is the point in space, and the texture coordinate, so it can like put some textures on that object. But as he asked where are the normals, you have to do that yourself now. So you have to say like, okay, I'm inputting like my vertex consists of a position and then normal and then the texture coordinates, and my position is like a vector 3, my normals are vector 3 as well, which is like where is it, this one, and my texture coordinates are just 2D, so it has to be RG only. And then you have to input like first position, like 3 values for the position, then 3 values for the normals, and then 2 values for the texture coordinates.
And does the order of the position, normal, and texture coordinates matter, or is it?
No, actually it shouldn't matter, because the position is actually this kind of semantics we talked about before.
Okay.
So the graphics card knows, okay, if it's position, then this is this. So that's why there is like fixed semantics, like the ones from DX11, because this has to be the same always. And there's this custom semantics which you cannot use position as like custom semantics, because the graphics card expects the position to be actually the position. You could do that in DX9 as well, but nobody really ever used it. It was the join mesh advanced where you can specify all the stuff. So this is pretty much still very DX9 style to create a mesh. The more interesting one and also the more performant one is actually the one we're getting to now. The one called with the one geometry topology. Because most of the time when you want to create geometry like dynamically, it's often a pretty simple one. For example, if you want to draw lines or just a strip, you don't want to say, okay, these are my positions, and you have the graphics card, please connect the first, the second, and the third to a triangle, and then the next ones to a triangle. You just want to push those vertices, like those positions, and the graphics card should like know what to do with it. And this is what the topology is for. You see, these are the points. I put a number there, and if you draw a point list, it will draw points, of course. But you can say, okay, these should be lines, a line list, so it will connect the first to the second, then take a break, connect the third to the fourth, then make a break. A line strip is, okay, connect each one, like everyone to the next one. And you can also do that with triangles. Okay, connect the first three to a triangle, then make a gap, then the next ones to a triangle. Or if it's sorted correctly, it will just automatically create this ribbon for you. So this is like super convenient if you know like this will be always in order. It will be always the same pattern how the triangles should be created with the vertices. You just have to input those positions and set the topology, and then the graphics card already knows what to do with that. So this one is called geometry buffer because we don't use this indexing anymore, which was saying, okay, the first three triangles are vertex 0, 5, and whatever. So this is always like sequentially, and you give the graphics card this flag, this hint, the topology on how to connect these positions with each other. Yeah. In case you want to do like more advanced things with that, you have to look up the MSDN site on how those topologies exactly work.
That's the link on the bottom in the patch.
Here. It should actually open with open, because you see there's like a lot more options how you could like give the graphics card your points. We just covered like everything from point list to triangle strip, but there's actually a lot more options. And
can also see, like, if you scroll down on a page, there's set graphics. For a triangle list, you have to pass the vertices in like in clockwise order. Otherwise, you'll have the triangle flipped.
Here it says, okay, it has to be this way, 0. If not, it will draw the backside. And so a lot of these features we're covering now, this is like exactly the implementation of DX11, like MSDN, like Microsoft did it. So this is just a node like wrapping it, but there's no like special magic behind it. So most of the things you can really look up in the internet, and you don't have to look it up as what does this node do. You can just put Google after the name, and you will see like forums or people talking about that, maybe in coding, but the names will all be the same. So this is pretty convenient actually. Any questions?
Is there an advantage to use one topology mode against another one in different use cases?
Depends on what you want to do, yeah.
No, I mean here, for example, you could do it with triangle list. Then you would start to duplicate. If you want to have like a closed ribbon here, you would have to start to duplicate the number 1 and the number 2, for example, to have it closed. And so you would actually send more data to the graphics card. So if you know you want to draw a ribbon, you wouldn't choose like triangle list because it has to be closed anyways. You don't want to like push more vertices to the graphics card than needed, because this is like most of the time this is the bottleneck to draw stuff, to get things from the CPU to the graphics card. So you would choose the most streamlined one. Or also for the same goes for the list, for the lines. If you want to draw like one consecutive line, you wouldn't use line list, because then you have to duplicate like the end and the start point to get it closed. Oops. One thing which wasn't there at all in DX9, which is super handy, is like the query or the debugging info. In DX9 you would just use the Perf Meter, and then you would see, oh shit, this magenta bar is like way too big, or I don't even know if it was magenta, but you would see, okay, it says GPU, so you would know, okay, something on the graphics card is taking way too long or is blocking like my rendering. And with DX11 you have this query output where you actually get a lot of information all the time on each node, how much time it's taking, how many pixels are drawn. So you see, so this pipeline statistics is connected to the constant. So I see, okay, this constant is actually drawing like 12 primitives. If I zoom into it, you will immediately see, okay, now it only has to draw like 7. And how many times does it have to call the pixel shader? So the smaller it is, the less it has to call it. And also if you scale down the renderer, this will of course also change because less pixels have to be drawn. So it's actually cool to like profile your patch, like your graphics pipeline, like which shader, for example, is taking too much performance, or which, yeah. You also have this on the, you can even have this on the renderer itself, so these numbers will be like added together. And it gives you pretty detailed information of everything. So whereas with the Perf Meter you only have this global time, like of all rendering together, now you can have it like on each renderer or each shader or each group even. So instancing is one of the super convenient features in DX11, which wasn't there really in DX9. You see here, traditionally you would do it like this. You have this linear spread, cross, you have 1,000 objects. You would just connect the spread to the constant to draw it, and send it to the graphics card. And here you see the timestamp, it needs like 4 milliseconds, I guess, to draw the whole scene, which is actually quite something for only 1,000 objects. And now you have this thing called instancing. If you switch it, you will see it takes like nothing of the time. and it still does exactly the same. And the trick is, since you're drawing like 1,000 boxes anyways, you just say, okay, I want to draw a box, but I want to draw this box like 1,000 times. And so you can, you actually just send this box like once to the graphics card instead of 1,000 times, and the graphics card does the duplication for itself. So what you're sending here is not a spread anymore, but it's instanced geometry, and you don't like send a spread of 1,000 transforms, but you send a buffer which contains like one buffer which contains like 1,000 transformations. This is called a draw call, like packing everything together and sending it to the graphics card. So with the spread, you would do like really 1,000 draw calls. You would like 1,000 times send a phone shader with one box with one color to the graphics card, then the next one. And with instancing, you can do like everything at the same time, which saves, like, as you can see, like takes 1/10 of the performance. And with instancing, you can easily like go up to whatever your graphics card. Don't push it too far. But you will see now, if I switch back to like it's still at my computer running with over 60 frames per second, and if I switch back to like traditional drawing, now it has to draw like 32,000, like it's 32,000 draw calls, and my computer is down to 10 frames per second. So this is how this draw a million particles thing is even possible with instancing. On the other hand, actually, like with very simple things like a quad with like just a color, DX9 was able to do that by itself. So if you had just a quad with a transform and you would draw 100 of them, like the ones which are still in the DX9, not the EX9 category, like the very old primitives of VVV, VVV would actually do that behind the scenes for you. You would sometimes see a warning in the TTY render saying, okay, switching to slice-wise drawing, if it wouldn't be able to handle that anymore. But this optimization is now gone. So if you have like a quad in DX9 with DX11 with a spread of 2, whatever, it will be for sure 2 draw calls. And in DX9 it was not up to a certain amount, but it was taken care of behind the scenes.
Another question: would it be possible to have like different sizes of the boxes, or?
Then you would also have to implement a size buffer, and then you depending on the instance ID, look up different size in the buffer.
No, actually you can have it here.
Here already?
Yeah, sure.
Ah, yeah, okay, yeah, sure.
With the transform.
Well, you can send it along with the transform. Yeah.
Oops, that was a little bit too much. Ah, man. They actually should be like different now.
Yeah.
If you turn down the number of boxes,
Ah, fuck, it's like, oops. I took the wrong count. That's why it didn't work. So yeah, it works. Oh, this would actually be a classic one to explain like noise. Quick demonstration on how, like, why you actually need like input, position input on a simplex noise. You have a lot of positions in space, and for each one it will look up a noise value. Okay, not so, doesn't look as promising as I thought. Oh man, okay.
Just the simplex do.
It creates a noise over a field. So actually I hope that you would see that noise is kind of, well, random is like really somehow, that noise would be kind of smooth, like.
Yeah, like positions that are close together get a noise value assigned that's also close together. So you have like a smooth transition between the sizes actually.
Okay, you see it a little bit here now. Like it's not a complete random information anymore for each point, but it just kind of makes sense in space. So actually now you see this noise. So it's kind of like always smooth to the neighbors. Yes?
If I wanted to give each cube a texture, I would have to do like a texture buffer.
That's actually a limitation. You cannot do buffering with textures.
Ah, okay.
Oops,
So
we didn't.
Then instancing would not be.
No. I mean, there is some
Texture
cheats.
array.
For example, you can use a texture array, but it's not the same, exactly the same. There's no dynamic buffer texture where you can just input a lot of textures. You can, and then a texture array is basically a 3D texture. So you have a lot of texture in space, and you would have to look up which one you want to use. But it's not as convenient as this dynamic buffer stuff.
Weiter.
No. So you know the deal from DX9, it looks pretty much the same. You have effects. You have the constant one, which is drawing like a constant color on an object, on a mesh. You have the Gouraud shading, you have Phong shading, you have Phong shading with directional light or shading with like point light. The new thing, that's still the template for creating a new shader, a new effect. But the new thing is that you have like texture effects, which did somehow exist in DX9, but not as convenient as here. In DX9, if you wanted to somehow work on a texture, an image, you would always have to create like put the image onto a quad and render it, and then take the have the, how was it called? DX9. DX9 texture. You would always have to take the texture back out of the renderer, and now with DX11 this is, you have the texture effects which actually does that in the background for you. So you can input a texture here, write some code on it, do something, and then you get a texture as output again. But still in the background it's still doing the same. It's still creating one quad, one renderer, placing it there, rendering it, but still it's a little bit faster because you don't have to have all these nodes doing stuff.
We'll have a look at it in the next chapter anyway.
Yep. Yeah, because now is the time when we start writing code, actually. Should we take a break?
Yeah, anybody else feels like?
Open the window.
Yeah, open
break?
the windows and get some coffee and then be back. Should we pause it?
So. Hier drauf.
Zu leuchten, oder? Das.
Okay, everybody. Yeah. So next up will be simple pixel shader writing, and so that's going to be like the first hands-on exercise. And like for all the examples, you'll find there will always be the folder exercise. That's our starting point. It's basically giving you a template from which you can then continue to work on. So you don't have to start entirely from scratch. And then there's next to the exercise folder, there's the result folder, which has got like the final result. So you can look it up in case you can't like keep up or something, then you can just have a look at how is it supposed to be later. And in case when following along, just raise your hand, Voy will help you and just go to you and help you find an error, or yeah, in case you got a question that's maybe interesting for the whole audience, just raise your hand and talk to us as well. All right. So if you open the in the second folder, which is called TextureFX, the TFX, that's just like for now the another small explanation to just cover again what I already told you. Here in the you basically now can see the difference to before. That's the DX11 version. That's the DX9 version. So here you basically just have one single shader and everything's basically taken care of. In the pass, I'll cover the anatomy of the shader in a second. They just have a pixel shader. So to just kind of compare it to the old approach, in here you like that's the old DX9 module, like texture effects template, and there was all this boilerplate code around which you had like to put there in order for it to make it work. So there's that render pass, and you had to like take the DX9 texture out of the renderer and pass it to the output layer. And here somewhere in between there, then your actual shader would have happened. So this still is happening, but it's been taken care of behind the scenes. So basically you'll always have still a quad with a size of 2 and a render pass. You just don't have to like take care of that. So that's basically all you need then. And just to, before we dive in, I'll just quickly explain what we see here. So basically this is some lines you will find in every other shader that involves a pixel shader, and all the main effects like constant or Phong, they'll all have these kinds of lines in there. So yeah, it will just be more if there's more than just pixel shader. So here you got a texture input. So this is basically the type, and this is the label you then reference. So this may now be misleading. If I wanted to add another texture, I just write it like this, and then later on, here I could then do the sampling accordingly. So that's the texture's name, which is then also exposed here as an output pin. So for example, like that, and now it should. Alright, I didn't clone the template, that's why I can't write to it. But you get the idea. And then basically this is a sampler, and the sampler is needed to look up the texture. So for example here you in the pixel shader you say, okay, sample this texture using the linear sampler, and that's that one here. And basically all you ever probably need to deal with is exchanging linear, for example, to point. So this means, for example, imagine you have a texture which is very small in size, for example 2 by 2 pixels only, and then you draw a quad on your screen in whatever bigger resolution, and you sample a texture which is that small. And basically then you need to sample the texture for every pixel on your screen, but the texture is just very small. So if you do linear sampling, then the sampler will just lerp between the values. So you don't have an actual pixel, you're somewhere in between the 2 by 2 resolution. So if it goes from green to red, then it will do all the colors in between as well. That's what a linear sampler does. And if you don't want the sampler to make up whatever colors, then it's point, and then it will just keep on repeating the pixel until it gets over that threshold. So the first half of all your pixels on the screen will be one color only, and then the next pixel. So this basically, it repeats stuff or lerps between them. And then this is also interesting if you get like texture coordinates. I'll just quickly explain them. So using paint, so this is a texture, and you're used to in before having the center here, so that's like 0, 0, and here you have -1, +1 for x, +1, -1 for the y-axis. So when thinking about textures, that doesn't apply anymore. Instead, up here there's 0, 0 and there's 1, 1. So they just expand from the top left to the bottom right corner. That's the texture coordinates. And you use these to look up a texture. So if you tell the sampler look up at UV 0.5, 0.5, that's the center then. And now what you need the address mode for here, which I just showed you. If you were, for example, trying to look up at a x coordinate of, for example, 2, that would be, like, for example, here, 1, 2. You can just imagine this to continue like that. And actually this is 2, 1. You get the idea. And basically if I would try to look up this texture at this point, it's basically out of bounds. So you have to tell the sampler how to deal with that UV coordinate. UV means XY, just in texture language. And clamp would basically mean that it keeps on sampling the last valid point, which is that one here in the corner. So it would just stick with that color value. Then there's also wrap. And what wrap does is, well, if you're then here and you're slightly above 1, then it will just wrap and continue on the other side again. So for example, 1.1 would be around here then. It's the same as 0.1. So 2.1 in address mode rep would be exactly that point here again. And then there's mirror, like this. And this basically means it just bounces off that edge. So if you were to sample 1.1 with a mirror mode for the address U, then it would be here and being the same as 0.9. Yeah.
You also see that behavior if you apply like texture transform. You know, there's this pin texture transform, and depending on the mode, it will duplicate in a different way. It will either be just the one picture, like smaller in the center or bigger, or it will start to repeat, or it will start to mirror onto the right and the left. That's the address thing.
Yeah, and you can put these, like configure these individually for the U or the Y, the V. All right. So that's the sampler. And basically, I guess we might as well just have started here in the bottom. The technique which you can set here is basically the technique pin on the shader, which you probably have seen already. So there you can give it a name, and then you define a pass. Here we just deal with a single pass. Which means in here I say, okay, look, please compile that shader function, which is referenced over, like defined over here, using the pixel shader 4 model, and yeah, use it as the pixel shader. So there's just one line in there. Later on we'll find a more elaborate shader where there's a vertex shader as well and geometry shader, but for now that's the basic thing. And up here there's the pixel shader, and this is the return type, float 4. That means it returns a color, being RGB and alpha, and as an input you pass the input object, a variable or struct in there, and you say, okay, please interpret this as being of type PS input, which is your struct over here. So this basically reads, we get this input of this type, and the type is defined up here. So I can then see, alright, I have a property P, which is SV position. That's also one of the shader semantics we already talked about in DX9. That was position only. Position is still there, but this is a special case because SV position is not now the vertex position, but as we're here dealing with the pixel shader, it's already in the view space. So basically that's already the pixels in like 512 and 483 something. And so we got the position of the pixel and the UV coordinate. So then you can see, alright, here I just take the linear sampler and I sample the texture using the UV coordinates which are found in my input. Makes sense? Cool. Yeah?
So the pixel shader is flow 4 pixel, PS is like a function?
Yeah, I could just say it's like that and just reference it down here as well.
But the PS input is like a parameter, and in the bottom where I'm the set pixel shader, compile shader, why I don't give the function parameter? You know what I mean?
Because it's passed through automatically.
Ah, okay.
If you have like vertex shader as well, these have to match. Like the output of the vertex shader has to be of the same structure, of the same struct as the input on the pixel shader, and the graphics card will automatically output, like route the output from one to the next. You cannot like specify them there.
Yeah. So yeah, for example, right here, if we had a look at the constant shader, there's 2 techniques down here, and that's like 2 pins on the shader here, constant and constant no texture, and you can see that they basically use like the one with the texture use a VS textured and PS textured, while the constant no texture doesn't use these versions of the shaders, but instead like a different function. And if I look at the difference between the PS and PS textured, I see they are also using different structs, or like they are differently typed. They expect different values for the input parameters. So PS input textures, they are all the way up here. So shader programming needs a bit of scrolling. If you add a value, you have to go to the top and declare it there, so that's going to be an issue later, I guess. A lot of scrolling involved. And here you can see that's PS input for no texture, so there's no texture coordinate here passed on. So I'm just handing over the pixel coordinate to the pixel shader, and the pixel shader version with the texture input, it also expects UV texture then. So it's not like you can define it at the technique, but instead like have everything duplicated in different versions and deal with that yourself.
And if you scroll down to the vertex shader, you will see that the vertex shader actually, the return type is the PS input and the PS input texture.
Yeah. So vertex shader comes before pixel shader. So the return type of a vertex shader is almost always the expected input of the pixel shader. There'll be cases, for example, if you have a geometry shader in between, then it might have not the pixel shader input, yeah, but the geometry shaders instead. But we'll cover that later anyway. Alright? Cool.
The only important thing for the pixel shader is that it is called like with the semantics SV target at the end.
Yeah.
You will see that if you don't have that, the shader, the compiler doesn't know that it's actually the pixel shader. It cannot deal with it. That's the only thing you have to write, like which has to be there in order to be a pixel shader.
All right. So that's the basic anatomy. So now we open the first actual exercise and write some pixel shaders. Yep. No. So there's the exercise folder, and you just open the TFX coding. And you can see, if you open the simple pixel stuff, you can see why we prepared a template for you guys, because we don't want to write all this by hand and do lots of mistakes. Instead, we just fill out the functions and let you know about the overall concept. So we'll start with the most basic one, I guess, which, if we scroll all the way down, you see all the different techniques we will now implement. So there's a multipass, which is the most complicated one for now. Then there's a invert grayscale. We get to mix some textures and do a very simple edge detection. And of course, draw a circle just with a single line of pixel shader code. And you see that they all reference different pixel shader functions, which are found slightly above. So maybe this is where I need more space, but I will zoom in on the code. Yeah, for now. Why does that? Ah, yeah. Well. All right. So let's start with the invert. So over here in your patch, right-click on the. Sorry. So in your patch, right-click on the invert here. So that technique is then being processed. And now basically everything you see on screen will be that shader here being evaluated. So for example, as a very quick test, that this one's the one we're now looking at, I can just, so this is the return variable, and that's like color, call for color of float 4. And I will now assign different color, for example, like red. And for this, I just write it like that, and then hit Ctrl S, and then the shader is getting recompiled. And now you can see I set the red channel to 1, green and blue to 0, alpha still being 1. Could be 0 as well, since we're not having any blend mode. And then you can see, okay, this obviously works. I'm at the right spot in my shader.
Does it work for everybody?
Okay, yeah, whenever I tend to go too fast through everything, so just give me a shout in case I'm too much in a hurry. So on the very top you could see that there's a texture input of type texture 2D, and it's called input texture in Pascal casing. So I now want to display that texture. So here in the invert function again, I will, instead of the float 4 here, I will say, alright, I take my input texture and I use sample, and probably over here we got a point sampler, which we then use. So point sampler.
Quick question.
Yeah.
I saw you had IntelliSense in there, and I'm not getting it. Is there a reason for that?
Sorry. Let's have a quick look.
So when you're typing, you got the suggestion.
Right. Yeah, sure. Yeah, in case you got the latest version of VVV in place, which just was released about a day before Node, then you have the kind of working auto-completion back. So for example, floor 4 color, I don't know. If you hit Control and space, the IntelliSense auto-completion thing will just give you some stuff. But it doesn't work, for example, for my input texture. It doesn't know what to do with that, sadly. So yeah, just works for the internal methods. Right. So I use like here the vertex data, which is my input data for the pixel shader, and then I think it's UV. Then I hit Control S, and texture should be displayed now. So instead of just displaying a single color like before, where I assign it a solid red, I now sample a texture input. You mean like that one? Control and space. Yeah. I'll just wait a second until everybody's.
Can you just
Yeah.
repeat again which variable is for what?
Ah, yeah, right. So basically, when I read a shader which I'm not familiar with, I start at very bottom. I have a look at the techniques. So, for example, we are now dealing with the technique T-invert. So I have a look at it here. Then I can see, alright, the pixel shader is set to the invert function. So I now start looking for that one. And I scroll up, I see the invert function here. And now I see it's expecting an input. The arbitrary name here is vertex data. I could set it to ASDF. That's just fine. That doesn't mean anything. It just has to write struct type in place here, which is VS to PS, which is just short for vertex shader to pixel shader. You could name it whatever you want. For example, before it was PS input. And then I just look for that up here, and there I can find it. It's very like densely written. It's basically just that here. So VS to PS, like pixel shader input is the pixel coordinate on the screen, and that's like the abbreviation WVP. It means like the position of a vertex has already been multiplied by the world matrix. So you put the object somewhere in space, then you have set it by the camera's position, and then you also multiply it with a projection matrix, which gives you like the perspective. And this results in where the pixel is on screen, and that's why exactly this is the SV position, like the pixel coordinate on screen. And yeah, the other one just being the texture coordinate. So here we now got the texture being displayed, but as you may can tell from the label of the technique, we want to invert it and like just invert all the channels of the texture. So that means, who knows what I have to do? Any suggestions?
You could subtract the color RBG from 1.
Yeah.
1 minus R, 1 minus B.
Right. And the cool thing is I don't have to manually go through all the channels. Instead I can just say, okay, return 1 minus the color, and then it's being basically 1 minus color red, 1 minus color green, and it applies it to all the channels.
What would you do with the alpha level?
It's also being inverted, but we're not displaying it anyway. So right now it would be like if we had a blend mode in place, then we couldn't see anything. And if we had a blend mode and would want the alpha channel to remain as 1, I'd probably go like 1 minus color RGB and just keep the alpha channel. So now I just put 3 channels plus 1, so you can also assemble a color like this and just process the channels individually.
So when you write 1 minus color, it just takes that 1 and it just makes it like 4 ones.
Yeah.
Yeah.
Each of them into
Basically,
one.
yeah.
It
Basically,
does that for you automatically.
yeah. It reads the same as, for example, return float 4 1 1 1 1 1 minus color. Same.
Yeah, yeah.
And also very handy. this also works, being the same, just slightly shorter. Yeah, I don't know, forget about it maybe for now.
And you can think of the variable col as being a spread of vector 4, as a spread of colors. So if it's 1 minus color, it applies it on like every slice, like on every pixel. So it's actually handy to know V4 because you know the concept of, okay, there's one pin, but actually this is a lot of data. And this is exactly what is happening in the pixel shader. So col, the variable holds like every pixel in this picture, and you can do operation like on all of them at the same time. So
yeah. All right, so that's the invert function. Then next up, yeah, okay, we do the grayscale here. So the grayscale technique is set to the grayscale function, so you can find it up here, and that's what we have the these coefficients here in place. So that's like called luma coefficients. Basically means that if you convert an RGB image to just grayscale only, you don't use all the you don't handle all the individual color channels the same, because our vision basically perceives every color at a slightly different lightness level. So you handle them different and then build a sum of all these. So basically in order to get these here into your shader, you just add a new line here. Just yeah.
Are these just random numbers, or do you?
No, it's just prepared ones.
Wikipedia.
That's yeah.
Okay.
This is actually from Wikipedia.
All right. Okay.
It's the ones that are widely spread. Yeah.
Okay. Yeah.
It's just some model. So in order to put them into the shader, I have to define a variable outside of a method here, outside of the pixel shader, and I could do that anyway. I could do it at the very first line on top. I just write it next to the function it's being used in, just for yeah, personal preference. So I just label it like this, cof, and hit Control S. And now you can see after it got compiled that here on the shader there's now this new input pin which is called cof. And since it's of type float3, it also has that XYZ built next to it just by VVVV. Yeah. And for example, as
it doesn't work, raise your hand. Huh?
Yeah, of course.
Sorry, the number after the float, it's the vector size.
Yeah, basically you can think of it as the vector size. Yeah, that's what it is. You could do that for all the different data types as well. So, for example, integer or unsigned integer 3, that would also work.
Okay.
And when you're like writing shader code, you want to stick with very simple variable names which are meaningful to you. But for example, in the patch, I'd like the shader to expose this variable as something even more meaningful. So you can add something to it in like these angular brackets. And it's the property UI name of type string, and you can set it to, for example, luma coef. What's the word? Like that.
That's
That's basically also done in other environments as well. UI name is pretty common. Vux could as well just implement some attributes himself. But for example, when you're writing a shader for the 3ds Max viewport, for example, it also uses the string UI name. And now I can compile it, and now it's I had to, in case it doesn't work, reset the node using Alt and right click somewhere in the node, and now it got the new name here. And I can connect it. And for example, there's even more. For example, UI min 0 or something, which means that you can't set the IO box to something less than 0, or you can just say 0 to 1 if you also set the UI max or whatever. So there's a couple of things. It's not too important for now, but just so you've seen it. Alright, and basically what we now do here is also sample the color, like the texture's color like before, and also of course set the technique in your patch to grayscale, so that function's being evaluated. And now you can basically, from the invert function here, copy and paste that line up to grayscale. And since we use the same naming for now, it should do just fine and return the color. So there was a simple copy paste from the invert function back to the grayscale one. And you should for now just see the normal texture without grayscale being applied. Right, and then can I move on? Cool. So there's now different methods to do that. One being, I'll just use another auxiliary variable, which I call grayscale. And actually, grayscale will be a single value, like a same value for every single channel. So it doesn't have to be a float 4. I mean, we could write it like this, but just doesn't make sense since we have to repeat it for all the other channels as well. So I just say, okay, float grayscale. And basically what I would now have to do is multiply the colors, like the textures, red channel with the coefficient also the first channel. So you can for all the floats here with the vector size, you can access the individual channels with a .r, or .x is the same, like x, y, z, w, or RGBA. So that doesn't make a difference. So basically now I multiply first part of the coefficient with the first part of the color. Then I add the same for green, coef y or g as well, plus color blue, coef blue, and then I can compile it. And yeah, of course you won't see any difference since we don't return it yet. So it still returns the original color here. So I just use the grayscale variable and output it here. And there you got it. And with these coefficients you can never go above, like the maximum value for a color in a channel is 1, at least in this case. And as all these percentages of lightness add up to 100%, even a perfect white would just be like 1 again in the end, yeah?
Can't you multiply the color RGB times the coef RGB?
No, that would leave you with the result of the one multiplication in the one channel, then the other one in the other channel. So you would still see colors in the pictures, just different ones. You have to build the sum.
Okay.
But there's a shorthand for this, which kind of is like what you suggested. So for example, I could as well just compute it like this with a dot product. And dot product basically is like color RGB. What? Huh? Cool. Oh yeah, right. Sorry. coef RGB. And this basically is already the sum of all the individual multiplications of the scalars. So that should actually be the same if I compile it. Yeah. So I can just show it just for reference. If you do like that, and I return that no grayscale value, yeah, sorry. Wow. That's just for demonstration purposes. So just doesn't make much sense. So that line here is not mandatory. You probably would just use something like this and just exchange it for that one. Yeah, it's just overwritten by the same value now. Yeah.
Every time I save the shader code,
yeah,
it loses the connection in my computer. It's not the connection from the.
Try alt right clicking on the shader, and then try it again. Maybe there's. You need a 3-button mouse, or you.
So I don't really understand. He's returned and not a float forward, just a float. And it seems to work on his, but it doesn't on mine.
Missing a semicolon before the whole story.
Oh, it's never to me like the web coding HTML. An inline attribute.
And I show you the magic numbers on screen.
You shouldn't be playing with those numbers. They're like constants. That's basically how much red should be affected individually or actual perception.
That's too much.
Here. Yeah. Yeah. Float function, what do you mean?
Just like
yeah. I just quickly check because so the question was, for example, if I comment out that line here and try to compile it, it says undeclared identifier. So the grayscale variable never has been like actually defined, so the compiler doesn't know which type it is. So you have to also put the float keyword here in front. That's basically all. Otherwise, it doesn't know which type it is. Yeah. And yeah, for the magic grayscale values, for example, if I just check on Wikipedia and look for grayscale conversion, then you can see here that's basically about these numbers. So 0.3. About 59 and about 11. So these are like slightly rounded. And there's also these, it's explained why it's being done like this.
If I change the type of grayscale to float 4, it also works.
Yeah.
So it automatically fill a float
yeah.
with the same value.
Basically, this is just a sum, so it's one single value. This is also just one single value. If you have something like this here, it will just write the same value to all the channels. So it's the same, yeah.
And you can also return just a float, the out float 4, and it'll just do that.
You cannot return a float because then the compiler will complain. I mean, you.
But we are returning a float.
Yeah.
Float grayscale scale.
Okay, it will automatically convert to float 4, but if you write like return float, then it will complain.
Okay, if you force it to float. Okay.
Yeah, just use it for the red channel now. And there's also funny flickering on there.
Maybe they're beyond the 0 to 1. No?
No, they actually can't be when using these, because if you like the maximum pixel value being white in a normal JPEG image will then also result in a I can show you here, like before you can just patch the 3D dot thing, and if I use the vector and multiply it with just once, it will also return a 1. So it can't be above the thing. I guess it will then just assume, okay, the float value I'm given is the red channel and all the other ones will be just black. Alright, then let's choose the next sample. Maybe I will not go through all of them, so we can, after the lunch break, then go on with the other stuff. So let me quickly show you something which might be interesting to not look up a texture, but instead like drawing actual shapes on screen with just shader code. So that's what we use the circle function here, like the circle technique, and it's referencing the circle pixel shader. It's somewhere here, there. So first in VVVV, set the technique of your shader to circle, so we start with all white again. And now it's getting pretty simple. I'm just assuming that we want to draw the circle around the very center of the image. Besides the center, I also need a radius. So radius is we go for as a variable, so I just write it here. So we now got a radius variable that's after compiling here in VVVV. It's there. And I set it to 0.5 for now. And basically, when thinking about this circle shape, you want to just see, okay, is a pixel within the range of a certain distance or not? So basically, I now have to just compare all the pixels texture coordinate to the texture coordinate of the very center. So basically that's like yeah, to measure the distance we use the distance function, and it also just returns a single value that's being applied to all channels anyway. So let's say I want the center, and since I'm talking about texture coordinates, the center, as explained before, is at 0.5, 0.5. And now I have to compare it to all the UV coordinates. That's like this. And this would also already compile. It would just give me a fading. Since I'm not using that radius at all so far. So you can think of it as a kind of threshold. So I just say, okay, if that distance is below my radius, then it's true, so it returns 1 for every single color channel. That's why it's drawn as white, and everything, all the pixels for which that equation is, or comparison is false, it's being drawn as black. And if I now here play in before with a radius, it also changes here. idea.
work for everyone?
So to show you what exactly happens here, I can display the vertex data, the texture coordinate. So if, for example, if I output the x coordinate, like x texture coordinate, you can see a fade from left to right. Here it's 0, so it's drawn as black, and here it's white. And I can as well just do the same for the y. So it's the other way around. So top and left is 0, and right and bottom is 1. And if I do it like this, I have to build a little something around here. Then you can see up here everything's 0. There's just x1 that's, and we apply it to the red channel. So here it's all red, here it's all green, as y is now green. And in between you see the mixture of the colors, and if a pixel is at 1, 1, with red and green mixed, it's being displayed as yellow. So that, just like to show you the texture coordinates. So 0.5 is here the very center. And I just compare like what's in range of all the texture coordinates around it. And if it is in range, draw it as white, otherwise draw it as black.
Are there any best practices regarding variable and shader naming conventions, something like this, like capitalization or anything? Is there any sort of...
Everybody does it different. So like there's this highly optimized Russian shader, some texture effects written by Uns, for example, and it's not human readable. Ah, okay. Yeah.
What's the level F standing for?
Ah, that's just interpret this value as a float. So it doesn't try to cast it to an int or like round it or like floor or seal it. Like actual that implicit casts to a data type are somehow important. For example, something like this will it doesn't do much sense now, but this will probably like not output what you expect it to do.
But if you put like a 0 point, if you put 0.0 at the end of something, won't it force it to be a float?
Yeah.
Yeah. Like 0.5, you wouldn't actually have to put that f there because it's 0.5, right? Yeah.
All right. So that's the circle.
Any questions to the circle?
Cool. Yeah. For example, what we could also no, we probably don't do it right now. I guess we got like 8 minutes remaining before lunchtime. Multipass. Yeah. All right. So what we do now is the multipass. So select the technique here. And basically what you can see here is that the technique will not just use one single pass now, but it will first take invert, then grayscale, and then mix it with whatever. And that's what we have yet to implement. So the invert function, we got that in place. The grayscale as well. Mix so far is not implemented. So let's do that first. The mix. All right. Or we just not use the mix one. Just.
I'm going to name the pass. And Press PV0, press P1.
You can name it whatever you want.
What is the use of that? Of naming them?
Actually, in V4 directly you cannot make use of it. You can make use of it if you're writing a plugin, so you can access it by that name, but like this, it's not really of any use.
Yeah. Yeah. So now actually, it's hardly visible. If you comment out the first pass as well, it will probably, no, it doesn't. Why doesn't it? Ah, yeah, right. So right now it just takes the input texture, and that one takes the input texture as well. So whatever you did here is getting overwritten. The texture is again sampled from the original one, and then the grayscale is applied. So in order for a pass to take the output of the pass before it, you have to also use semantics. So if you sample a texture, if it's the first pass, it will always take the initial input texture anyway. If I set this to previous, the compiler will say, alright, the input texture in the grayscale one, which comes in the pass after the invert, will now not sample from the texture you pass to the shader, but instead take the previous result of the last pass and process this when you reference input texture. Then the input will get overwritten by the result of the last pass. So that's what the previous semantics up here is for. Everything else, all the examples before, will work exactly the same. Previous in the first pass will be the same as initial, so it doesn't make a difference if you just stick with one single pass.
Imagine it like being for the first pass, for the invert, it's really the input pin, and for the second pass, it would be like if you had like a link from the output pin onto the input pin again. That's the previous one. So for multipass, it will always take the result of the previous one, so it's kind of a loop. So you can process the picture in one shader function and then call another one and do additional processing on it instead of always taking the file texture which you loaded above. Yeah.
Tell us the shortcut for the comment.
Yeah, it's control and hash.
Yeah. So now you've seen that the multipass, writing a multipass shader is very simple in DX11. I just randomly opened an old DX9 effect, texture effect, the glow one, and had a look inside the module. And here you can see that all this, for all the every single pass, so you can see here's a glow, here's a glow, and here's a glow, and they are all set to different passes. You have to pass the texture on to the next one and repeat all the same stuff and duplicate it and have a lot of boilerplate nodes on the VVV side. And luckily you don't have to do that anymore. Instead it's just like single line down here, just adding it there and putting the previous semantic next to it.
Well, behind the scenes it's actually doing all that.
It's happening anyway, yeah. So that's still an actual render pass. Yeah. Mix. All right. Got 2 more minutes, so we do the last one. Oh no, edge detection will be missing, but you'll find it in the result folder anyway. Or if you want me to explain it, I can do so as well. So let's say mix, and I guess it makes sense to mix one texture with the other texture. So first what we need is a second texture input, and to do so I just go up here, copy that line. I can yeah, have it at the previous semantic as well, it doesn't matter, and I say label it other texture. So that's up here, and now down here I'll first, as always, sample my first texture. Missed that. And now I have to sample the other texture as well. There should be an output pin here now, but it's not. Right, so I do get rid of the previous, since apparently I can't have two of them. Now it's there. So now the shader exposes the other texture to the patch, and I will just I now just input another texture into the shader, which I can mix the other one with. So to do that really quick, I just use the assets module of DX11 type, and it returns whatever texture from a system folder. Yeah.
Just for cosmetics, can you tell them to have the pin on the left-hand side for the other texture?
If you reset, like the pins are created in the order where they show up in the code, but while you're coding, they will always like be added to the end. But once you restart or recompile reset the shader, it will like have to be in order. But while you're still changing stuff, it will always append to the right.
Yeah, but if I reset the node, the texture still is stuck here, even though it's the very first declaration. Now that's surprising. Yeah, it doesn't want to. Well, for plugins, you could do it. You can set the order of a pin to be leftmost. For shaders, you're now just yeah, exposed to that bug. I'd consider it a bug, maybe. Yeah. Alright, so to sample the other texture, I first have to input another texture here. I just use whatever the assets module is throwing at me. It just reads out certain folders of your Windows installation where there's demo pictures and system pictures and whatever. So there shouldn't be anything offensive in there. And now just to have this one in there as well, just copy and paste my sample line. I mean, I'm always a copy and paste guy. I also often don't remember all these different semantics, so I just look it up and copy and paste it over there. It's more important that you know how it works instead of to write everything from scratch. So I call the other color, and I sample from other texture. So that one has to be the same as the texture name up here, and other color is just an arbitrary name. And now I could just return other col, and it outputs the Windows 10 start image. So I can now, for the return the one or the other texture. And when I want to mix them, I imagine I need a fader to fade between the one and the other texture, and to do so I introduce another variable which is of type float, and I name it mix value or mix fader. And if you were to implement that type of slurping, of mixing yourself, then you will want to say, okay, so let's set it to something meaningful first, like 0.2 maybe. And then what you basically, if you would write that function yourself, you take like mix fader by color, one minus, so it takes 80%, like 0.8 of the first texture into account, and then you just add like 0.2 mix fader by other color, just add them together. Huh? Oh yeah. Never forget how math works. God, yeah, sure. Now I got it. Cool. And now you can just use the fader to fade between the two. And I just wanted to show the math behind something that's way more easy. It's just a lerp function, like linear fading between two values. And you just say, okay, color, other color, and use the mix fader as the value you wanted to fade between, so that works just the same.
Basically input more.
Yeah.
I guess because with previous, the compiler has to do some magic to have the output back up again, and it can only do it for one pin.
But is it possible to, I mean, if I have two pictures and then do something with it, filter, but
I think in a I think within a pixel shader you can use two of these textures. I can imagine that a second previous works. Well, no, it actually that doesn't make much sense. No, you just return one single image per pass, and then you just sample from the one you added the previous two before. Yeah. So no, there's no point in doing that.
This is not like standard DX11 semantics. This is something that Wux implemented for convenience, and it does only work for one. Like this trivial initial thing you won't find in any DirectX documentation. So just here.
Yeah. So we are 7 minutes over time. So in case there's no more questions, we meet here after lunch break.
You can still put it in the mix pass. That's the one comment.
What? Right. So I now can uncomment that and say multipass, and now it does all three together here. So you can also see that there's the mixing of that image as well.
It does only apply the first two lengths to the first image and to the second one. To the first image.
Yeah, because you sample it from an output pin, like an input pin, and only the texture, the first texture with the previous word next to it. This is the one that's being passed on to the next and the next.
You would have to mix first, and then to invert the grayscale, and then it would apply to both. You can just change the order, and then it would